Here is your review for your final Algebra 2 classes. We're going to start by looking at only the problems that you really need to focus on. I'll help you most on your final. We're going to start with this problem right here, number 3. What is the vertex? Well, everybody can see that vertex right there. It is at -2, -7. And this opens up. So it has a minimum value, -7. There is no maximum value. End behavior. On this left side, as x approaches -infinity, right there, as x approaches -infinity, f of x approaches +infinity. On this right side, as x approaches +infinity, f of x also approaches +infinity. Decreasing is as if you were riding a roller coaster going down. This is decreasing, and then increasing going up. So you have to have decreasing to have increasing to have a minimum. So our decreasing goes from -infinity up to, and then it's right there on the vertex at -2. Decreasing and increasing is always with the x-axis. So we go from -infinity to -2, parentheses, bracket. And then at -2, it changes. Right here at -2, it changes. And it goes up, 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 up. So we start with -2 and go to +infinity for increasing. Remember, this is the roller coaster. So if you're looking at your graph right here, what would happen if I decided to stretch it? Take this graph and just stretch vertically, vertical stretch by 2. Well, obviously, I didn't say we were shifting left, right, or up, down. So we're going to stay right here at this point and go up. So if you stretch vertically from this point right here, your range is going to start at -7 and go up. We didn't move the point. We just stretched it. We just pulled it up. So our range, y, is going to be greater than or equal to -7, because that's where our mid was. You can also put this in the calculator. Absolute value. We'll do that with a later problem. Just want to make sure you know that you can do that. If we did, the shift left 2 would be in the absolute value, and down 7 would be on the outside. And then there is a compression. Notice it's up 1 and over 1, 2, 3, 4. So it's 1/4. So I just want to make sure you know how to put it in the calculator. So once you turn your calculator on, the way that you get the absolute value is you have to hit the math key. And when you're on the math key, you scoot over and see there's your absolute value in the number. One more time. Math key, scooch to the right, and then hit enter because that's absolute value. Okay? And that would be your absolute value bar, right? Let me put this whole thing in. We're going to go to our y equals and put it in so you can see that it matches. So we're going to start with 1/4, 1 divided by 4, scoot to the right, and then we're going to hit our math, scoot, enter, and inside we're going to put x plus 2. We're going to scoot to the outside, and then we're going to put -7. And we should have the graph that is right here on our screen. So let's hit graph. And does ours match? It sure does. There you go. And you can always check your points to make sure. Alright, let's move down to another section. And let's just talk about the transformations. We're not going to work this whole thing since we did that one right before. But let's just talk about the transformations. Out here on the outside, the negative means it reflects. So instead of opening up, it opens down. So negative means it reflects over the x-axis. On the inside, you have a 1/5. That is a horizontal stretch. Horizontal stretch by 5. On the inside, you also have a +2, which does not mean we went to the right, it means we shifted to the left. 2. And the +6 means you're going to shift up 6. That's it for this front page. Let's turn to the next page. Alright, on the next page, let's talk about the transformations and then let's solve this. So transformations, the 2 on the outside means a vertical stretch of 2. The plus 6 means we shift to the left, 6. And then if this 4 was on the other side, the minus 4 would mean we shift down 4. Alright, since we're solving, let's go ahead and isolate the bars. So we're going to divide both sides by 2, get the bars all by themselves. So 4 divided by 2 is 2. Now because we have bars, it means we have 2 solutions. First, and we're not going to pay attention to this right here, we're going to do x plus 6 equal to 2, and then we're going to do x plus 6 equal to negative 2. So we're going to subtract 6 on both sides, x is equal to negative 4. Subtract 6 on both sides, x is equal to negative 8. Those are your 2 solutions. Alright, we're going to switch gears and talk about quadratics. So on this one, well actually just graphic. Don't pay attention to the graph equation, let's just pay attention to the graph on 13. I drew a graph here and I want to know the domain and the range. So notice where the domain starts. It starts right here at positive 4. So x is greater than or equal to 4. And our range starts right here at negative 4. So y is greater than or equal to negative 4. What if they asked for interval notation? Interval notation would be from 4 to positive infinity for domain, right? This is our domain. And for range, it would be from negative 4 to positive infinity. So I want you to see it both ways. Alright, number 14. Not only are we going to graph it, but we're going to identify the vertex and the y-intercept. So our vertex right here is a positive 2, negative 3. Positive 2, negative 3. So we'll go over 2 and down 1, 2, 3. Put a dot. Now our vertical stretch is 2. So that means it goes up 2 over 1. And then again 2, 1, 2 over 1. And so on. And so on. Let's do that wrong. 2 over 1. Okay. What if I asked for the y-intercept here? Well, the y-intercept is when x is 0. So this would be 2 times negative 2 squared minus 3. So it would be 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 would be 5. Huh. Right 2, down 3, I did that. Vertical stretch of 2, up 2 over 1, up 2 over 1. That should be 5. Let's see, let's put in the calculator. Oh, this is a parabola. I don't know why I'm doing that. I'm so sorry. My apologies. Okay, because we did absolute value, I'm thinking absolute value. So, that is not right. Our vertical stretch is 2, which means over 1, up 2, over 1, up 2. And then the next one would be over 2, would be plugged in a 2. It would be up 1, 2, 3, 4, 5. Okay, that's what I did wrong. My apologies. That's what I get for doing too many things at once. More than what was asked on the equation. Okay, let's go ahead and put it in the calculator just to make sure Ms. Frost is right. That's so sad. Alright, so we've got 2, open parenthesis, x minus 2, close parenthesis, we're squaring that, and then on the outside, minus 3. Okay, let's see if it actually, yep, it does, right up there at 5. So it should have crossed up here at 5. And you can go to the table and see. There it is, 0, 5. My apologies. There's our vertex, 2, negative 3. Right there. Okay. Next time I'll just put on the calculator. Let's go on to convert to vertex form. Number 16, you're going to use x is equal to negative b over 2a. So our b is a -4, and 2 times 1 gives us 4 over 2, which is 2. So your equation, since this is a positive 2, would be -2 squared. And then over here we want the d, what we would plug in. So you would plug in the 2 squared minus 4 times 2 plus 2. 2 squared is 4 minus 8 plus 2, -4 plus 2, -2. So it would be -2 on the outside. And we can put this right in the calculator and get it quickly, much faster than what I just did. So x squared minus 4x plus 2. If you hit graph, you can see the vertex right there. And you can go to the table and read your vertex. And notice that 2, -2 is that low spot, which is 2, -2, 2, -2, which is exactly what we got. And you can put it right in there. So your axis is symmetry, x equals 2, and vertex was 2, -2, and vertex form, we already put it right here, and the y-intercept, y-intercept, when x is 0, 0, 2, 0, 2. Okay, that's everything there. We have 2 more problems we're going to do. Let's look at this one right here. So first I want to look at our directrix and our equation, and we want to know if you're given a directrix and an equation, a directrix and a vertex, could you come up with an equation? So what is the vertex here? Our vertex is 2, 0. So the equation is that y is equal to, and in the parentheses, since we move to the right 2, we put x minus 2 squared. On the outside, we don't have to put anything because we didn't go up or down. And then this coefficient would come from the directrix. Notice that directrix is 2 above, right? So the little formula says that it's 1/4 of p, right? 1 over 4p. So it'd be 1 over 4 times 2, which would be 1/8. Don't forget that this is opening down, so we have a negative. So you can write an equation from what you have there. In addition, what if we've restricted the range? What if we only went between 0, it's right there, and 5? Well, if I restrict the range between 0 and 5, I'm only going between here and here, right? Well, the low right there is at -4, and the high is at 0. So we go from -4 to 0. You can also do this by just looking at your graph and see where your high part is and where your low part is. Make sure that the x and the y match. Remember, that's your low and that's your high. Okay, number 21. Based on the equation that we have, let's see if we can, the graph that we have, let's see if we can write an equation using A, C, and D. So, our C, because we did not shift left or right, is just the x squared. And our d, since we shifted down 6 minus 6, y equals. Now what about our a? This looks like a vertical stretch of 2. You can see that it goes up 2 and over 1. So y equals positive 2, x squared minus 6. Alright, that's it for your video for page 1.